Good morning, everyone. We are Wednesday, July 12th. And so today you're ending your unit 2. So there is an assignment for you to do. And then we're starting unit 3. So hopefully everything is going well and you were able to do your independent study unit check number 1. I'm going to be marking as soon as I am done all of this, so you will have an upgraded mark on EDSB. And yeah, so here's assignment number 2. It does seem long, however, it's not too much math for you to do. Just gonna keep scrolling. Okay, here we go. Okay, so today we're looking at shapes of distribution. So we're just going to do a quick review on histograms. So we have example 1. So earthquakes are measured on scale known as the Richter scale. Their data are a sample of earthquake magnitudes in Canada between 1960 and 1965. So here's the data here. What is wrong with each of the following histogram display above the data? So I'm going to move this. I'm going to do it here so I can type. Okay. So this one, we can see that the width of each bar is too small. Too small of a bin width results in a histogram that does not effectively summarize the distribution. Between 5 and 10 intervals will usually produce a good bin width. Okay, so as you can see, the bars are way too small, so it doesn't represent the data too well. Whereas this one, we have pieces of data. Wow, that's not how you spell pieces. Of data fall on the border of 2 intervals. This makes it ambiguous as to where the data actually falls. Make sure to take the necessary steps when creating your intervals to make sure that this doesn't happen. Okay, so if you look here, this one and this one, as well as this one, they fall on a line, which isn't very specific. So this could be interpreted as 2, when in reality it could be like 1.8 or whatever we think. Okay, let's make an effective histogram for the data. Okay, so we have to determine the range of the data. So, no. Let me get my pen. There we go. Took a second. Okay, so determine the range of the data. Okay, so the range, we find it by doing our highest value. Okay, so you go up to your value, find the highest one, and then your lowest value. So if you were to go back and look at the data, our highest is 7.2 and our lowest is 4.6. So you're going to subtract the 2 and it gives you 2.6 as our range. Okay. To find an appropriate interval width that will be dividing the data into 6 intervals, what you do is, so your equation is bin width is equal to our range divided by the number of intervals. Okay, so we found that our range is 2.6. We have 6 intervals, so that gives us 0.5 as our appropriate bin width. Okay, so I am going to clear this. Determine the first value of your interval. So, we added 0.4 to 2.6 when we rounded our range. Therefore, we should subtract 0.2 from our smallest value of 4.6, which makes our starting point 4.4. However, some data will still fall on the border of the intervals. So we should add a decimal place by subtracting 0.05 from our starting point. Okay. I'm not too sure what's going on here. Oh, okay. So I am going to clear this so I can scroll down. So note that if you have rounded your range up, you should subtract half of the amount you rounded from the smallest value to evenly distribute the excess of your range. Also make sure no data points lie on the border of 2 intervals. Do this by subtracting 0.5 from whole number, 0.05 from data with 1 decimal point, 0.005 from data with 2 decimal points, and so on. Okay, so we are going to create a frequency table using the intervals. So notice that the number 1 interval ends with the next interval starts with the same number. This is because the data for a histogram is continuous. Okay, so our interval here is 4.35 to 0.85. Okay, so it's got a 0.5 difference, which is the range that we found, or the bin width, sorry. And so it just tells you where to start, where to end. Our next interval is 4.85 to 5.35, 5.35 to 5.85, 6.35, okay, and it goes on and on. Okay, so if you were to look at your data, you've got one that lies between here, 13 here, 12, 6, 5, and 3. Okay. So I'm going to clear that so we can create our histogram. So we found, whoa, this would be by 2s. We have our intervals 8, 10. This is the frequency. Let's see if I can write sideways on this thing. Oh, not too bad. Not great either, but, and this is our magnitude of earthquake. Okay, so we found that this guy is at 1. This guy goes to 13. So you guys have rulers and things, so it'll be a lot better. The following one is at 12. The next one is at 6. Following one is at 5. And the last one is at 3. Okay. I'm just seeing something real quick. Okay. So I'm going to clear this. Hopefully yours looks a lot better than mine. And we're going to take a look at shapes of distribution. So step back from histogram. What can you say about the distribution? So when you describe a distribution, you should always comment about 3 things. So it's shape. I'm going to try the spotlight thing. Okay, so it's shape, center, and spread. Okay, so in this lesson, we will focus on shape. So the mode of a histogram is an important characteristic that is often used in describing its shape. The mode of a histogram is the interval with the highest frequency. So does the histogram have a single peak, central peak, or several separated peaks? These peaks are called modes. Okay, so the shape of distribution is generally described in one of 4 ways. Okay, so our first one is it's in a U shape. The second one is that it's uniform, so it's all the same. The third one is that it's mountain shaped, so like a mountain, and skewed means it's all over the place. Okay. And so for the first 3, those are all symmetrical. Okay. So these guys are symmetrical. Okay, so a graph is roughly symmetric if the right and left sides of each graph are approximately mirror images of each other. So I'm going to clear this. We're going to take a look more specifically about these. Okay, so we've got the U-shaped distribution. So the scores from the game of Spider Solitaire from this type of distribution. So as you can see, it's a U shape. It's pretty symmetrical in the sense that this one and this one are the same, this one and this one, and so on. A U-shaped distribution occurs when there are peaks at either end of the range. Because it has 2 peaks, it can also be described as a bimodal distribution. Okay, so I'm going to clear this. So can you think of another example of a frequency distribution that would be U-shaped? So the best example I could think of is marks on a test where half of the class just didn't get it. Okay, so I'm gonna clear this. Oh, I like how my avatar yawns at me. So this is the distribution you would expect from an experiment such as rolling a single die. Okay, so this is pretty uniform. They're pretty well all at the same outcome. So when each outcome has a similar frequency. It is called uniform distribution. The height of the bar is roughly equal. So it's not the same, it's not a full line across, but they're pretty darn close. And notice there doesn't appear to be any one single mode. So mode being your peak, right? I am going to clear this and we're on to the mound shape. So rolling a die or a pair of dice and recording the sum results in this type of distribution. So you've got your mode here, which is your peak, and it kind of makes like a mountain. So in this distribution, there's an interval with the greatest frequency in the middle. And the frequencies of all other intervals decrease on either side. The frequency distribution takes on a mound or a bell shape. It can also be described as unimodal, since it has one clear peak or mode. Okay, so I'm clearing this. So we did say that the first three are symmetrical. So some similarities that we have between the first three shapes of distribution are that they are roughly symmetrical, like we had mentioned. However, we do have skewed. So the thinner ends of a distribution are called tails. If one tail stretches up farther than the other, the histogram is said to be skewed to the side of the longer tail. Another way to say it is that the interval or group of intervals with the highest frequencies are near one end of the histogram. As a result, the distribution seems to tail off to the left or right. Okay, so I'm going to clear this and we're going to finish up this lesson. This distribution of ages of female heart attack patients is, so you can see that the peak here is leaning on the right side. So you say that it is right skewed. Okay, and this one, you could see that the mound is on the left, and so you would say that this is left skewed. So I'm going to clear this. It just says, so if you get mixed up between left and right skewed, look at your toes. Yeah, that's really it. So that's the end of our lesson for today. Hopefully that makes sense. Hopefully it's something that you've seen before. And yeah, good luck.